Hello. In this example, we're going to graph f of x equals x plus 1 divided by 2x squared plus 5x minus 3. To graph something like this, the first thing we're going to want to do is we're going to want to find the vertical asymptotes, which actually allows us to find the domain. So the vertical asymptotes occur wherever the denominator equals 0. So in this case, that's 2x squared plus 5x minus 3, and I would set that equal to 0. We can factor this, and some people like to guess and check, some people don't. If you like to guess and check, fantastic, feel free. But I want to go ahead and show how to do this using the bottoms-up method. Now, the reason people find this difficult is because there's a coefficient out here of 2. So I'm going to bring it over here to the 3, and we're going to multiply. And off to the side, kind of, just do x squared plus 5x minus 6, because this is an entirely different problem that we're factoring. But it makes it easier. So the factorization of x squared plus 5x minus 6, well, first of all, there's an x here and an x here. Now this is a minus sign, and to get a minus when multiplying, the only way you can do that is with a positive and a negative. Ask yourself what multiplies to 6 and subtracts to give you 5. Well, that's 6 and 1. And notice I put 6 with the positive because the 5 is positive. Fantastic. Now, the 2 was what we multiplied by, so we're going to divide by 2. And we're going to simplify. So that's going to give me x plus 3 times x minus a half. Now notice that this is not the factorization. This is just kind of an intermediate step that's kind of like side work. Just remember, anytime you have a denominator, and you will, bring it up in front of the x within that factor. So the factorization is going to be x plus 3 times 2x minus 1. And I would still set that equal to 0. This first factor gives us the solution x equals negative 3, and the second factor gives us the solution x equals positive 1/2. Okay. Now that we have the vertical asymptotes, we actually know the domain. The domain is everything except for these two numbers, and here's how you write it down. It starts at negative infinity and goes until the first number here, which is negative 3. Then we start again at the negative 3 and continue to the next number, a half. And then we start again at that half and continue until infinity. So this is how you write down everything except for negative 3 and half. So this is the domain. The next thing we need to look for is the horizontal asymptote. To find the horizontal asymptote, we need to look at the degrees. What's the degree of the numerator? Well, it's 1. What's the degree of the denominator? 2. So because 1 is less than 2, we have a horizontal asymptote, and it is y equals 0. Next, we need to look for any x-intercepts. To do that, we set the numerator equal to 0. So the numerator equals 0. The numerator in this case is x plus 1. Well, x plus 1 equals 0, subtract 1 from both sides, so x equals negative 1. And because it's an x-intercept, the coordinate would be negative 1, 0. Now, the y-intercept, x is always 0. Then look up here and notice that this x becomes a 0, this x becomes a 0, and this x is a 0. The only thing we're left with are these constant terms. So we have the 1 divided by negative 3, which in this case is negative 1/3. So here's the y-intercept, here's the x-intercept. Now notice that for the x equals negative 1 here, the x-intercept, the multiplicity was negative 1. Sorry, the multiplicity here was 1 because there was effectively a parentheses to the first power here. And so because of that, at this x-intercept, this is actually going to cross the x-axis. Now, the other question becomes, does it cross the horizontal asymptote? And the answer is yes, it does, because y equals 0 is the x-intercept. So it crosses at that -1, 0, or at least touches. Okay, so let's plot everything that we know. The first thing we want to do is we want to plot the vertical asymptote. And the vertical asymptote is x equals -3. 1, 2, 3, fantastic. So this is x equals -3. The next thing we want to do is we want to graph x equals 1/2. Well, that's about right here. It's a little bit difficult to draw this, but there you go. Now notice that I'm using a dotted line here, and the reason I'm doing that is, well, frankly, because the dotted line is not a part of the graph. The same thing about the horizontal asymptote. The horizontal asymptote is the x-axis, in other words, y equals 0. Next, I want to plot the x-intercept, that -1, 0, and the y-intercept, 0, -1/3. I want us to look at what's happening here. Because these 2 points are right here, we have to connect those. But at this -1, 0, its multiplicity was 1, so it crosses the x-axis. But we can't cross this vertical dotted line, think of it as a brick wall, and we must continue all the way to it. But we also can't go down because there are no more x-intercepts. So what that means is that this function must approach this vertical dotted line like that, going up to infinity that way. Also, the same reasoning happens over here. There are no more x-intercepts here. So this function will have to continue down along this vertical asymptote. However, look at the x equals -3, x equals 1/2. Because they have multiplicities of 1, that you can see right there, the function crosses the x-axis. In other words, from this -3, it's going up this way, so it needs to cross the x-axis down to the other side over here. And we're going to go back up towards the horizontal asymptote. And the reason we do that is because that's what the function approaches as x gets really, really small or x gets really, really large. And I'm just kind of, randomly guessing like this. You can put down more points if you want to be a little bit more accurate. Same thing over here. If we're going down to the -1/2, it's going to flip to the other side and go down like this towards the x-axis. Alrighty, this is the graph of f of x equals x plus 1 divided by 2x squared plus 5x minus 3. I do want to show you what that's going to look like on the graphing calculator. So what you're going to do is you're going to graph this. Now here's the thing. If your calculator is older, you're going to have to do this like this. You're going to have to use a parentheses and then type in the numerator, the x plus 1, close your parentheses, and then divide by parentheses, then type in your denominator. So it gives you 2x squared plus 5x minus 3. Then you'd close, and then you would graph. However, if you have a newer calculator, you can press this alpha here, and then press y equals for that function 1 button. And notice that there's an n over d there. So if you click that, that's going to give you a square over square. In other words, you can type this in exactly the way it looks. So you're going to type in x plus 1 divided by 2x squared plus 5x minus 3. Fantastic. Either way works. And if you have a calculator that can do this, but you want to do it the other way, that's fine as well. But it honestly is a lot easier to do it this way. Now let's graph this. So here's what you would see on your standard window. Fantastic. Notice that this right here is your vertical asymptote. Some of your calculators may actually put a vertical line there, but most of them now won't. Same thing here. And notice that you can see it crosses at -1 there, and it crosses at -1/3, and you can kind of see that it looks like this. But here's the thing. If I see on your graph that you do something like this, start here and just go like that, and then you do something like that, and then you do something like that, and you stop, I'll know that you just looked at the calculator and you're just copying what it says. You can make it look like this, yes, but you have to make sure that you put these arrows on there as well. Alrighty, well, I guess that's it for this question. I will see you next time. Oh, and have fun.